Okay, next problem. Oh, actually, just a word on the last problem. I ended it up, and as soon as I shut off the video, I said, well, I should probably mention this. Some of you might be confused. The change in momentum of the ball when it hit the wall and bounced off, the change is 25. So the 25 was the change. And that change in momentum applied to the ball is also going to be applied to the door. The door wasn't getting momentum at all prior to being hit. But then if the you push on me, I push on you comes into play here, boom, boom, 25, 25. So we're going to have a difference of 25 from both of them. Okay, so that's why the door would move more. All right, now, next problem. Number 4 on the sheet, number 3 we did last week. Betty has a mass of 80 kilograms running to the right at 4. Veronica is moving to the right as well. Betty and Veronica, anyone? Come on, Betty and Veronica. The Archies, yes, very good, the Archies. We all know about the Archies. Or not. Okay. So Betty and Veronica. We'll give her shorter. Hey, they're my stick figures. I'll put the hair on them, but I want to. Thank you. Let's see. Betty has a mass of 80 kilograms running to the right at 4 meters per second. So 80 kilograms. 4 meters per second. And Veronica is moving to the right as well. 60 kilograms, 3 meters per second. 60 kilograms, 3 meters per second. There we go. Now what's going to happen? Betty is going to crash into Veronica. Catches up. Makes like Heinz. Catch up. Heinz. Catch up. And they stick together. They're both wearing Velcro sweaters. Stuckage. After the collision. Ooh, it's a collision problem. What is their velocity after they collide? Okay. I mentioned in the last video it was called conservation of momentum. Muy importante, grande. Momentum before something happens equals a momentum after something happens. So if we set, there's an equation for it, you can write it all, but I just like drawing pictures. Pictures are worth 1,731 words, more than 1,000. I've actually counted how many words pictures are worth. Trust me, 1,731 words. It's a lot of words. So if we draw pictures to represent what's happening, we can equationize it by using our pictures. Okay, let's finish out this drawing, because they collide, right? They stick together. So this is before the collision. Conservation of momentum says momentum before and after a collision is going to be maintained. We're going to have the same amount. So before they collide, they have a certain amount of momentum. They're both moving, and they both have mass. Then after they collide, they stick together. So let's see. Okay, see? All stuck. What would their total mass, now that they're moving together after the collision, be? Well, it'd be the masses added up, the 80 plus the 60. So together they're moving with 140 kilograms of mass. The question in this problem is how fast are they moving? What is their velocity? Let's use conservation of momentum ideas to solve this problem. It's not a hard problem. It's really not, trust me. Look, it's nice and soft. It's not a hard problem. It's nice and okay. The momentum of Betty is going to be 4 times 80, or the mass times velocity. So that's 80 times 4. Now, this is the total momentum. We need the total momentum before they collide. The total momentum is Betty and Veronica. Betty plus Veronica. And that's 60 times 3. Total momentum before. Betty, Veronica. They're both moving in the same direction. Because some of you are sitting there with your hand going up, wait a minute, what about the direction thing? So if they go one way and they go the other way, we have to have different things, positive and negative. Well, they're both going to the right. So they're both positive. So I don't have to worry about it in this case, maybe in another problem. In this case, no. Both going to the right, they're both positive values for their momenti. Plural for momentum. Look it up. Don't believe me. Okay. After they collide, their mass is 140, and their velocity is, don't know. That's what we're trying to solve for. So this becomes a relatively simple algebra problem at this point. So that's 320. And units are kilogram meters per second. I'm just not writing them out. And you're going to divide by kilograms, so we will get meters per second for a velocity answer. This is 180 is 140x. 500. So 500 equals 140x. Divide by 140, and we get x. It's 1, 2, 3, 4 point something something. Okay, let's see. 500 divided by 140. Oh, eyes. 3.57. 3.57 meters per second. We'll see if that answer makes sense. Hopefully it should make sense. Veronica is moving faster. She collides into Betty, loses energy, changes her momentum. She lost some energy, changed her momentum, her momentum should go down. Her velocity should go down. Well, her momentum goes down too, but her velocity should go down. She was moving it forward, she collides, she's going slower. Yep, she's going slower. Betty got whacked from behind. She was moving slower and she got whacked from behind, which means she's going to gain energy. She should increase her velocity, and she went from 3 to 3.57. Makes sense. So this answer is between two velocities. All good. All right, that's problem number 4. Ooh.